Hello, and welcome to this video which will explore the pattern of solar radiation across Europe using the C3S Climate and Energy Education Demonstrator tool. Here we see a map of Europe displaying the average amounts of solar radiation each country receives per year. As we cycle through the historical record, you'll note that the pattern remains the same, with Southern Europe in darker oranges showing that they received more solar energy compared to countries in Northern Europe appearing in pale yellows and so receiving less. Let's change the map to a finer spatial resolution and split up these countries into smaller regions. The pattern we've just described becomes clearer. Regions in Southern Europe receive around 220 watts per square meter on average per year, compared to those in Northern Europe receiving around 70 watts per square meter on average per year. But why is this the case? Southern Europe is close to the equator, but a common misconception is that the equator is the hottest part of the Earth because it sticks out towards the sun. However, the Earth is 150 million kilometers from the sun, so this distance makes no difference at all. It is actually to do with the curve of the Earth. The sun strikes areas that face directly towards it more directly itself, as demonstrated by the lowest beam shown, whereas areas tilted away from the sun receive less intense solar radiation because it is spread out over a wider area. The Earth's tilt is what gives us our seasons. In the Northern Hemisphere's winter, this tilt means that Europe tilts away from the sun, and so these sunbeams are less focused and less intense. So, Europe is cooler. Whereas in the summer, the Northern Hemisphere tilts towards the sun, and the sun's radiation is more concentrated. This is why Europe is warmer in the summer. Going back to the map, let's have a look at these seasonal differences a bit closer. First, let us look at the average solar radiation for winter. Finnmark, a county in northern Norway, received an average of only 0.03 watts per square meter in December 2016. That's hardly any solar radiation at all. Whereas by contrast, Sicily in southern Italy received around 78 watts per square meter. Compare that to the summer of 2016, in this case June, the month of the summer solstice. Northern Norway received 171.42 watts per square meter on average, which you'll note is more than southern Italy in the winter. But this still cannot compare with southern Europe. For example, Sicily received an average of 321.07 watts per square meter in June 2016. Let's finish by looking at this wonderful time lapse from Tromsø in northern Norway, showing perfectly what the differences between summer and winter amounts of solar radiation looks like. You will note that in the middle of winter, Tromsø only experiences a few hours of daylight compared to the almost 24 hours of daylight in the middle of summer, all due to the curve and the tilt of the Earth. Thank you for watching. Please do visit the tool using this web link here to explore more about solar radiation patterns across Europe and how they are projected to change going into the future. Also feel free to use the hashtag C3SEduWemc to explore and share experiences of using the tool. Goodbye.